All right, guys. So I had just don't forget we crossed these out the other day. We weren't going to worry about those, so we're going to jump into Thursday here, which is about parent functions right here. All right. So basically, the idea of a parent function is it is a graph or an equation that goes with the graph. Okay. And that equation, which is literally considered, well, both of these together are considered a function. Those, so it's a basic graph or equation that uh, you can use to easily sketch a graph. Okay, that should be the word sketch. All right, so here's the deal. There's more than these guys, but this is the basic idea of what you guys know already. This is that constant function here. They call that f of x equals a number. So we did that like 5 the other day, if you guys remember, right? Okay. This is your basic straight line, y equals x. Okay. All right. And then your absolute value ones are always a v shape right here. And then your quadratic ones, x squared, are always this shape. So if you see any type of squared like x plus 3 squared, that is going to be a U-shaped graph. Okay? If you see anything with absolute value signs like f of x equals absolute value of x plus 2, that's going to be a V-shaped graph. All right? So we just got to make sure we understand that that's what we're dealing with. We're always we're looking for the function so we know what the graph looks like. So we've got multiple translations. So we're gonna talk about this, and I'm gonna kind of dial it in here in a second for you guys. So a translation here, a translation is going to move this thing up or down, or it's going to move it left or right. It's going to move the parent function. So let's look at this one here. Describe the translation. This just means since it's on the outside, it went up 2. So it went up 2 units. So this number on the outside tells it to go up or down. Okay. So the number on the outside tells it to go up or down. So we use a V shape because it's X bar, and X bars are always V-shaped graphs. Okay. All right. So now, what's the translation on this one? This is a V-shaped graph, right? Absolute value, and it's going to be moved up. It's not up. It's inside. So inside, it always moves the opposite of what you see. So this one's going to move left. Whoops, I can't even write today. Always going to move the opposite of what you see, and I'll explain that here in a minute. It's going to move left 3. So if I was to draw this one, we have our base parent graph right here, and then we're going to move over 3, and my new graph, which is this one, I'm going to draw at 3 as a V because it moved to the left 1, 2, 3. Okay, so let's look at this one. We got a U-shaped graph. So I take my graph here. I have a parabola-shaped graph that goes like that. What does the number on the outside tell us? It tells us to move up or down. And since this one is negative, we are going to move down 4 spaces and draw our new graph because the translation was down 4. Okay? All right. I'm going to pull it all together for you guys in a second. So a reflection. So a reflection means that it jumps across the x or y axis. So if we've got something here, a reflection means it kind of looks like this. You have, if it's a negative in front, like this, if it's a negative in front, it flips over the x-axis. So if this is the x-axis, it flips over and points down. So for a negative in front of the function, so a negative, if it was pointing up, it makes it point down. And if it was pointing down, it makes it point up. Okay, so it flips things. So if one side was pointing up, then it would be pointing down. Like you see here, we know that the base parent graph is x squared. So this is the base parent graph. So we've got x squared here. But this one here has the negative in front of it. So it flips over and it reflects across the x-axis. So a negative in front flips it upside down. So let's look at this one here. Okay, so let me draw this one. So our parent graph here is absolute value of x. So that's this guy, right? So we've got that one. It's a V shape. I can't draw it very well. Man, I missed that completely, didn't I? So it's a V shape, but I have a negative in front, so therefore it reflects on the x, which means now it's going to point down on the graph. Okay? So it's going to turn around and point down. All right, let's look at this one. Let me change this one. So our parent is y equals x. So that one looks just like this. It goes like that. But I have a negative in front. I have this negative in front. And that tells me I'm flipping across the x-axis. So my new one, let me draw purple again. Oops, not that one. Nope. We're going to do purple. Yeah, I'll do purple for the XY axis again. But now it's going to tell us to flip it. So what's pointing up now points down. And what points down now points up. So that's my new y equals negative x. So anytime it's out in front, it reflects over the x-axis. All right. So a dilation just means this. It means that it's going to shrink or expand the graph. People call it steeper because I'm going to make my answer 4 times greater. So in other words, my answer will be 4 times bigger than it normally is. So if x equals 1, it'll now be 4 because it's 4 times x. So if you look at this and we do y equals 4x, if I draw my y equals x, like they did here, it's just going to be my parent function. Oops. My parent function is just y equals x. That's my parent. But it's telling me now that the 4 is going to make it steeper. So that means for every x value I get a y value, it's got to be bigger, 4 times bigger. So if this one is 1, the new one is at 4. So if I go up to 2, 3, 4, it's just going to be a lot steeper. And so my graph gets a lot steeper. I've got to learn how to draw those better. Okay? So my graph gets a lot steeper. All right. So that's why there's a difference in it. So this makes it shrink and expand. All right. So let me double check. Let me show you that one. So if the number in front here is greater than 1, it gets steeper. If the number in front is less than 1, it gets skinnier, not skinnier, it gets flatter. Okay? So let's look at this. So we're going to take our parent graph here. What's our parent graph? Our parent is equal to x squared. So that is going to be a parabola like that. And then my new graph here is 2x squared, which means it's going to be a lot steeper, so it's going to be skinnier. It's going to be a lot skinnier. So this makes it skinnier. Notice how this one's wider than that one? So that means that it's steeper. Skinnier is steeper. So then we look at this one, and we've got an absolute value graph. So what's my parent graph? Let's go purple for parent. So my parent graph is y equals the square, the absolute value of x. So that is a V-shaped graph. But I have 1/3 in front, which is less than 0. So I'm going to take my next one, and it's going to be the absolute value of 1/3 of x. So that means it's flatter. So I can quickly sketch graphs depending on the information that they give me. All right. So we've got this big, huge summary here. So it talks about if f of x plus h is greater than 0, it translates left, it translates right. I did those arrows backwards. It translates, I did it right. Left, and this one translates right. If it's outside, okay, so let me do that, mark that up a little differently. So let's look at this one. If it's inside and h is a positive, it moves to the left. If it's inside the parentheses and h is a negative, it moves to the right. If it is outside, like k is here, it moves up or down. So if k is positive, it moves up. If k is negative, it moves down. Notice the difference between the two. There's a difference between these. Okay? All right. Here's our number in front. We call this letter in front A. All right? So this is considered, this little piece here is considered A. If A is negative, it reflects across the x-axis, so it goes from up to down or down to up. This negative inside here is considered B. That reflects it across the x, so it goes left to right. It reflects it across the y-axis because it has to do with the x. And then our dilations have to do with our letter A in the front also. So we're going to kind of pull this all together. Okay, guys? So let me show you something. I have 3 different things here. Let's just work with the 2 that you're going to work with the most. So if I have f of x equals negative 2 x plus 1 squared minus 3. Let's talk about this. We're going to call this a bx minus h plus k. That's what this is. A, B, H, and K. It's all what we just talked about right up here. So let's talk about this. This negative 2, the negative 2 is going to do what? It's going to flip it or reflect it. So we'll call it flip. We're going to make that word reflect down. Okay? this here, it's positive, so h is equal to -1. Why? Because, so you're like asking, why is that the case? Because negative h, negative h is equal to 1. If I set those equal to each other because they're the same, negative h equals 1. And if I divide both sides by a negative, h equals -1. So take that off here. I don't want that. H equals -1. So that means it's going to move to the left 1. Okay? Now we look at here. K is equal to -3. K means it's negative, so it's going to move down 3. So now I've got a few things going on here. This is what I mean by you can sketch it quickly. I am flipping it over and pointing it down, and it's going to be a little bit skinnier because 2 is greater than 1. I am moving it to the left 1 because h is -1, and I'm going to move it down 3. What am I moving? I am moving a parent function. So my parent function is x squared, which looks like this. That's my parent function right there. Let me write that bigger, guys. My parent function. Let's do this. Okay, so this is my parent function. So my parent function looks like that. It's a parabola. But I'm going to take it, and I will do it in the highlighter. I'm going to flip it over. I'm going to move it to the left 1 and down 3, and flip it over and make it a little skinnier because of the 2. And that's it. Okay? So that is my reflected, flipped, and translated. So this is I translated it to the left 1 and down 3 because of this guy right here. And that one. It's H and K. All right? So that's kind of all you're doing today. Don't forget that you can check. You can, I'm going to say it again. I'm going to keep saying it because they're super helpful when you're stuck. We're going to do a couple in class to start tomorrow. And then you can also look at the PT. So that's what they're talking about there, is how to flip and translate parent graphs. Just remember this key piece right here, and we'll talk about it again tomorrow. Right here. A parentheses bx minus h plus k. And we'll get that going tomorrow right at the beginning of class. All right. Good luck, and we'll see you guys soon.